Stars for Stars legend, wait for it, Dairy Learner Show. Brought to you by the amazing Mrs. Smith.
Good morning, boys and girls. How are you today? I miss you so much. Just want to start off every day by telling you I want you to know how much I miss you and how much better this would be if you were right in front of me. So let's go ahead and get started for the day. And today we're going to talk about the associative and the identity properties of multiplication. Now, I know it's been a while since we talked about those properties, and I'm going to go ahead and split my screen, and I already have my other pulled up so that you can see the notes that I'm taking so that you can have the same thing in yours and that way you know you have all of the same information that I do. All right, so let's go ahead and start off. So I have my title already written. And then I have like a chart so I can look at them side by side. So I can compare them, and let's go ahead and start with our first one. We're going to start with the identity property right here. Remember, identity. What is identity? When you think of an identity, think of like an ID. An identity is who you are, right? So imagine the identity property is like looking into a mirror and you get to see who you are. So when we look at it, the identity property is the property that we use in multiplication that states that the product of any number times 1 is that number. So let's look right here. The identity property. Let's put it into words. So it says, and we want to go ahead and put this into our notes just to refresh our memories. It always helps if you write it down, and research shows that the more you write something down, the more likely you are to remember it. That's research. All right, so the identity property is the property that states that the product, sorry, boys and girls, that pen was not wanting to work. The product of any number and 1. So what they're saying is when it says of any number and 1, that means any number multiplied by 1 the product equals that number. All right, so let's break this down. It says the product of any number and 1. So that means what they're talking about, any number and 1, because product is the answer to a multiplication problem. So any multiplication problem that has some number multiplied by 1, my product or the answer to that is going to be that number. if we look at our examples right here, so 5 times 1 equals 5 because it's like a mirror. Remember when we said the identity property is a mirror? So this 5 looks at itself in the mirror and it sees itself, a 5. Same thing for 248 times 1. It's still 248 because any number times 1 is that number. Let's go ahead and I want you to pause the video and go ahead and solve these. It should take you less than a minute, but I want you to write out the problem in your journal. Pause. And all right, so I hope you had and you paused enough time. So let's look at our examples. And it says first 45 times 1 and 45. 1 times 10, 1 times any number, the 10 sees itself in the mirror. It sees 10. 1 times 36, any number, so 36 is our number, times 1 is that number. 210 times 1 is still equal to 210. Great job. Now that one is an easy one. Should be pretty fresh on our minds. Let's look at this, which is the kind of problem that you could possibly see on a test. Which choice is an example of the identity property? Well, so we're looking for something that has a 1, A and B. I don't see any. There's no ones, not any number that's multiplied by 1. C is our only answer. The associative property. Let's move on past the identity property and let's look at the associative property. And the associative property states that you can use this property to multiply 3 or more numbers, and it doesn't matter how you group them, that the product will stay the same. So think back, and we're going to talk about this a little bit tomorrow. The commutative property, it didn't matter what order you put the factors in. So now we're looking at the associative property, and it doesn't matter how we group the factors. So the grouping of the factors does not change the product. Okay, so let's look here. If we're looking at 3 numbers, because that's what it says, that if we're multiplying 3 or more numbers, so here in our example, we're given 3 numbers. The first grouping that they use is to say, okay, in order to solve this, I can use first, I can group 4 times 1. And I know that 4 times 1, because of the identity property, 4 or 1 times any number is that number. So 4 times 1 equals 4. And then I just need to pull this right here, and 5 times 4 equals 20. Let's look at it a different way. If we take our same 3 numbers that we had before, but instead of grouping the 4 and the 1 together, I know, because I like fives, and I know that 5 times 4, if I do that first, is 20. And then I bring this down and I multiply it. Well, then I'm back to the identity property, and that's really easy. So 20 times 1, any number times 1 is itself, is that number. So 20 times 1 equals 20. The product stays the same, but I just figured it out in a different way. That's what the associative property really means. We can group them. See, grouping. We're using what we call parentheses to show grouping. Parentheses show grouping. If you can write me a private message and telling me that parentheses show grouping, I'm going to think of something special, because I'm really upset that people aren't watching my videos. And I can't do cartwheels. There's not enough room right here. All right, so let's look at this. This is showing the associative property. So let's write our example, and it tells us our 3 numbers are 4, 3, and 2. And I can see that because there is a 4, a 3, and a 2 on each side. But they have a little bit different grouping if you look, because in the first one, they've grouped the 3 and the 2, which means I can do 3 times 2 is 6. Bring this down, and 4 times 6 equals 24. Now, let's check and see if we group them differently, the product should stay the same. Great job. So let's see. Over here, they group the 4 and the 3. And I know 4 times 3 is 12. And I bring this down. 12 times 2 is 24. Is 24 equal to 24? Yes, so that means that each side of the equal sign has the same value. Remember, the equal sign means the same value as. Let's look at these examples. And our first one. If I look at the left side of the equal sign, I can see that there is a 4, an 8, and a 5. So over on my examples, and I wrote a little bit too big, so I'm just going to have to go over to the back page, and that's okay. And I want to title it so I know that this is continuing. So these are the associative property examples. First one, we see a 4, an 8, and a 5. And then there's an equal sign times 4. Well, if over here I'm multiplying and my factors are 4, 8, and 5, well, that means that if I have a 4 and a 5 over here, what factor is over on the left side that you would need to put on the right side to make these balanced so that you have the same factors on each side. Great job. I would need to put an 8 right here. And if we look right here and we want to go ahead and solve it, 8 times 5 is 40. Bring down your 4 times. Remember, this is a tens number, so I can look at what is 4 times 4. 4 times 4 is 16. I know that because 4, 8, 12, 16. I can skip count really quick. And then I slap my 0 on. Over here, they were grouped a little different. 8 times 4 is 32. And then times 5. This is when we like to use the associative property because this was a lot easier to figure out than 5 groups of 32 or 32 groups of 5. But really, we were wanting to know what number, what digit goes in that blank. What is 32 times 5? It should equal 160. Okay, second one. Doing a great job, boys and girls. I'm given this as my problem, and I like to go ahead and write it out. And I always want to make sure that I'm writing it exactly like the problem says. And I can see on my left side, there's a missing, but on my right side, I see the factors 6, 5, and 7. What factor is missing on the left side that you don't see, that you actually see on the right side? Great, a 7. So a 7 goes here. And the reason that we can figure it out, if I go to this side, 6 times 5 equals 30, and bring down your times 7, this is a tens number, so 3 times 7 equals 21, and then slap your 0 on. Because if it's a tens number, remember, a tens number always has what digit in the ones place? Great job, a 0. That's why I can slap that number on. If I were to do it this way, I would need to say, okay, well, here's my 6 times, and 5 times 7 equals 35. Well, 6 groups of 35 isn't as pretty as my tens number multiplied by a 1 digit. It would still equal 210. And last one, I want you to go ahead and pause it and make sure that you understand exactly how to do this next problem before we go over it in just 1 minute. I'm going to go ahead and write out my problem. Go ahead and pause the video if you need to at this time. Okay, so if you still need a little bit of time, keep me paused. Now, if I look over here, I see that my factors are a 2, and a 9. Over here, not worrying about the parentheses, I see some number, a 2 and a 9. So I know that this number, the only factor missing from the right side that I see on the left side is a 2. Now I can solve it. 2 times 9 equals 18. And if I bring this down, 2 times 18, remember, 2 times any number is that number plus itself. So it'd be like 18 plus 18, and that equals 36. Over here, I know 2 times 2 equals 4, because that's in the parentheses. I solve it. Bring down my times 9. 4 times 9 equals 36. So they equal the same. They have the same value, The left side is the same value as the right side. 4, you have a short Google form about the associative and identity properties. Don't rush through it. Make sure you're reading careful. Remember, those tricky tricksters still like to put tricky questions in there to try and trick you. So be very careful, boys and girls, and do your very best. And I'm still missing a lot of tests on SchoolNet. And some of you I've reminded repeatedly, so please make sure you get that done. All right, boys and girls, I hope you have a great day, and I'll see you tomorrow. Bye.